Okay, so welcome to all of the new people. We have about 50 people registered through IEEE, and it's nice to see you all. This is a roundtable for open source work from Open Research Institute and folks in the San Diego IEEE. So thank you all for coming. So please stay muted, and if you would like to participate in the roundtable after the usual suspects are done, then that's totally fine. So welcome everybody. This meeting is recorded and will be put on the Open Research Institute's YouTube channel and also advertised through the San Diego section of IEEE. All right, so it's 10 o'clock. What we're going to do is go ahead and start. Welcome. This is Open Research Institute's FPGA Meetup. And what we do every week is talk about what we've done over the past week in open source FPGA design and what we have planned for the next week. So a retrospective and also future plans. Then we talk about if we have any roadblocks, anything that's getting in our way or preventing us from doing these projects. And if we need any resources, anything that Open Research Institute, this is a 501c3, so it's a nonprofit in the United States. If there's anything that we can provide or help you get. Okay, and what I'm going to do is I'm going to post the agenda over in chat again, because I probably didn't see it. It was posted earlier. That's our agenda for today. And after we go through these items, what we do is we go into open discussion. So it's a question and answer, or folks can share anything that they have from open source FPGA work. Okay, so to start, Aaron, you have the floor. This is OpenCPI updates from Aaron.
Hi, Michelle. Thank you. So last week, I've been continuing to work on the CI pipelines. I've hit some, I wouldn't say roadblocks, but I'm already past them. But it's combining GitLab's CI, GitLab runners with Vivado and Docker. Just we use these in OpenCPI, but once you set them up, you don't really you forget how they're set. So there's some settings with PIDs that Docker and Vivado are required to play nicely, so it could run through generating a bitstream through CI pipelines. So that was fun this past week. So now I haven't successfully created an SD card image yet, but I've gotten past my blocker of generating a bitstream. So I've got a bitstream. So I'm getting closer to get to the point, and I'm targeting 4 platforms. So the Pluto SDR, which doesn't have an SD card, which is a little bit different, the LibreSDR, the ZC706, and the ZCU 102. So in all my debugging, I've only been doing LibreSDR, and as soon as I get that one working, I can get the other ones working as well. So that's what I'll be working on this coming week, is finishing that up. So the ultimate goal is to get SD card generated with everything required to stand up the same demonstration I showed a couple of weeks ago. So in addition to that, I've worked on a application within OpenCPI. It was really updating the original one I made a couple months ago with the log power FFT. So taking a wide band of the spectrum, 20 to 40 mega samples per second, and then taking the log power FFT, and then taking the bins and displaying them kind of like just a spectrum viewer. I had one for MQTT as a transport, and another one as ZMQ, I believe. So I created a new one that uses UDP packets as a transport of those bins, of that containing the data of those bins, and being able to transport it. So then I took that, I got that running on the LibreSDR, and so I separated the receiving of that data, and then another app that receives it and displays it. So now there are 2 separate apps, so that they can be different devices. So I created another application that combined the transmitter from the DVB-S2 transmitter and this UDP spectrum viewer into one application. So now we're doing both. So at 40 mega samples per second, we're receiving calculating the FFT, sending that over UDP to the ton interface, and then the ton interface encapsulating that in GSC, sending that over the DVB-S2 encoder, and then going to the receiver of the mini tuner receiver, and then displaying that data. So actually getting somewhat useful data through the system with this application, activating the receiver on the FPGA and the transmitter both at the same time. So I've got that working on the LibreSDR as well. Everything fit in the bitstream. So that is working, and I do have a image to share. I can pull that up real quick. So here is in the very back, this is the browser on the computer connected to the mini tuner showing the spectrum, which is just the FM radio broadcast. I don't know if that zooms in for you or not, but on the left is the OpenCPI app, and then we have Wireshark showing the data, the bin data. Then the log my ND receiver with can kind of see the constellation, the QPSK constellation, and then the two different apps that take the GSD data, put it back into another ton interface, and then the UDP receiving application. So got that working. Okay, so that's good and all. So that's what I did last week. This coming week, I'm going to start shifting gears a little bit. Well, obviously, first thing is finishing the quick start guide so that we can get the. I know Paul's been updating me with the status of the FMC cards. So as soon as those come in, he has something to test with and get this up and running in the lab. And did I lose? And then after that, my plan is to start tackling Opulent Voice in OpenCPI. Yep, I think that's all I got, Michelle.
Right. Thank you. That's fantastic. And for those that are not familiar with OpenCPI, would you like to say a few sentences about OpenCPI, what it is, and where folks can find out more information about this particular open source framework?
Sure. So OpenCPI is a heterogeneous framework geared towards enabling FPGA, software-defined radio applications. And the idea behind it is, you write your application once and then be able to port that application across OpenCPI compatible platforms. And that's what we're showcasing here with the four platforms I've mentioned. You can find more information about it at opencpi.org.
Very good. Yeah, we're making as much use as we possibly can of this because we do deal with a lot of different SDRs and FPGAs, and being able to do this. This is a ongoing problem, friction point in a lot of engineering with FPGA designs and in SDRs and DSP. Is porting is very expensive and problematic and error prone. And anything that makes it easier is excellent engineering. So thank you, Aaron.
You're welcome.
All right. Next up is Opulent Voice work. We have some updates there, and I'm going to give the floor to Paul to tell us what's been going on, and I can add details as needed.
Okay. But we did achieve, got partway toward achieving a new milestone of actually transmitting over the air between houses here, which meant setting up a whole new station. We found some interesting things. We discovered a problem with interlocutor and keep alives that needs to be tracked down. Seems to have something to do with configuration files. Michelle will probably be able to give more detail on that.
Yeah, sure. No, I'll just give a little bit of background for the folks that are listening. And so, Opulent Voice is a digital protocol, open source digital protocol, designed for UHF and above. And this is a minimum shift keying modulation. And what it does in the protocol is it combines your voice, keyboard, chat control, information control packets for like authentication, authorization, or any other sort of control messages, and also general data into one stream. In from the amateur radio or experimental perspective, usually what we dealt with is a digital voice protocol where you had to switch to a separate packet mode in order to transmit data or chat or anything else. And we didn't like that. So we combined this. There's priority queues. The voice will always win because latency is critical for voice. But it just basically backfills and fills in all of the different types of data in a priority queue. That was one of the reasons that we designed, yet another digital voice protocol. And the other reason was that almost all of the VHF, UHF, and microwave digital voice protocols use the AMB codec at a relatively low bit rate. So these are low bit rate vocoders, and they're proprietary. AMB is proprietary. Now, Codec 2 is not. That's an open source codec, but it tops out at like 3,400 bits per second. Opus is another open source codec, and we went with that. And our baseline design is 16 kilobits per second voice, which sounds pretty darn good. So instead of struggling to identify the voice on the air in public safety surveys, public safety uses digital voice and they use a AMB codec and it's all low bit rate. The complaint over and over again for many years was fatigue in struggling to listen to dispatch or your other emergency responders or public service responders. So we figured it was time to really address both of these issues. The combining of data and voice needs to be done more intelligently, and also the low bitrate codecs are really very frustrating, and that's why Opulent Voice exists. So really good voice quality, and also all of the different types of data are combined into a stream in a smart way. So when we talk about Opulent Voice, that's what we're talking about. It can be used terrestrially, point to point. It can be used terrestrially in a repeater system. And our goal here, though, for amateur radio satellite service is to provide an amateur radio satellite that has Opulent Voice as the uplink. And Aaron discussed the circuits and the downlink design. So when he talks about DVB-S2, that's our downlink that combines all of these different uplinks and then packages them up in a DVB-S2 frame and sends them back down to a station that then can hear any or all of the streams of data. So when when we're talking about these sorts of things, Hypharia is the project name for the satellite system. And when we talk about a ground sat, we're talking about a repeater that combines all of the Opulent Voice uplinks. So when we're trying to move from the lab and conducted testing, so all of these links work conducted. There's a hardware VHDL modem. There's also a C++ software modem, and they're working. And now we're trying to get it to work over the air, which, as you know, is the real test. So it doesn't work until it works over the air, and that's what we are trying to move towards, which means filters and caring about a lot of things, regulatory things. So we got really close to being able to achieve that last night, and I think that over the next week, we'll be able to go ahead and prove that out. I hope that gives a little bit of context to the folks that are here, that are kind of listening along. And yeah, okay, back to you, Paul. What are the other things that we need to cover?
Okay. I want to call attention to a blob of text that I plopped into the Slack conversation a week ago today, a little bit less than a week ago because it was after the meeting, about what I'm calling multi-session COBs. Right now, we multiplex the different kinds of information, which are primarily voice, keyboard to keyboard chat messages, control messages for the system, and everything else, which we call general data. And we multiplex them using a very strict priority queue method where whatever is the highest, which is going to be voice because it's the real-time service amongst all of those things, gets to own the whole channel while it's transmitting. And then when it finally ends, then any backlog of chat messages will go out, and any backlog of control messages. I guess the other way around. Control messages first and then chat messages. And then any bandwidth that's left is allocated to any general purpose data. If we have that, we don't quite have that interface built, but that's coming soon. And that's a little bit not optimum in terms of channel utilization, especially if we switch over using the Opus vocoder from a fixed rate mode where it fills the whole packet every 40 milliseconds to a variable rate mode where it only uses as many bits as it needs. Um, in that case, when I pause for a second or two, like that, that's channel capacity that could be used for other things. The voice is still going, the vocoder is still putting out a packet every 40 milliseconds, but it can be a little tiny packet that just says more silence, or or something of that nature. The exact details are buried in the Opus codec. Thankfully, we don't need to worry about that. But we just turn on variable rate mode, we get all these little pieces of a packet that we could use if we were a little bit smarter about how we multiplex. And right now, the method we use to multiplex them is called COBS, which stands for consistent overhead byte stuffing. And it's a way to delineate the boundaries of packets in what's otherwise a continuous stream of bytes. It's been known for quite a few years now, but has never really become a standard or caught on in any mainstream application on the internet, as far as I know. But it's still a really clever method, and it's better than anything else uh, that comes to hand. It's very low overhead as well as consistent overhead, so it's a nice way to do things. But it really assumes that there's one stream of packets, and we have multiple streams of packets that we'd like to multiplex together. So I think with a little bit of hacking around on the COBS protocol, we can create a multi-stream version of it, and then uh, text messages that you chat while you're typing, or that you type while you're chatting on voice, can get through before the end of your voice transmission, maybe little by little, but they'll get through, and that's better. We could make it even better user interface if we had more bits than we needed for voice, but everything about Opulent Voice is optimized around voice. Every packet is just big enough for a full voice packet every 40 milliseconds, like clockwork. And so we don't have extra, but we can use stuff that otherwise goes unused. So I would encourage everybody who's interested in this to go read my block of text on Slack, where we discuss technical issues like this, and tell me what you think. Give me ideas. I'll try to make it more formal over the next some while, and then try to implement it.
Yeah, what we can also do is put it in the newsletter and also out on the mailing list. And so if you want to tighten it up a little bit and, just a little, don't let perfect be the enemy of good, as we say, but spread the word about this particular proposal, because you are taking the COBS essentially standard, and bending it just a little in a way that really serves a use case that I'm sure a lot of people on this call are familiar with. Um, you can fill out an entire frame with zero padding, but if you have an opportunity to have a variable rate vocoder, for instance, or any sort of variable rate code, then you have unused capacity. And just like in sending rockets to space, we'd rather put additional payloads in there than concrete blocks, right? So that's what we're kind of talking about here. So yeah, we'll get the word out about your proposal. Um, and credit to you for bringing COBS up and getting it into the protocol in the first place. It is serving us extremely well. What it does is it allows us to have basically arbitrary length data, and we now know the edges of the data. So on the other side, when you get 97 packets, you know that they're all related to a text message, and you can just reconstitute that with very low overhead, well, consistent overhead, which is really kind of key for protocols like this. So thank you for all of this work. It's deeply appreciated, and we'll get the word out in the March newsletter.
Okay, yeah, it's a good idea. I think that's about all I have to report this week. We've
Okay.
got hardware coming in for radios for Aaron's project. Seems like there must be something. Oh, there is. No, that's all the same. Never mind. Nothing else to report about stuff coming in.
Okay, no,
So
thank you. Yeah, I think the getting this to work over the air, because we're at least the way that we kind of approach radio work is that it doesn't work until it works over the air. And this is kind of an extension of the it doesn't work until it's tested mindset. So and also we're very demonstration forward. So getting something that can be demonstrated at any of the upcoming events is very important to us. So we like that. We know that like a paper because we do articles and papers, and proving out the math is one thing, and you have to do a good job understanding the theory, applying it and implementing it, and then that whole process, iterative process of going back and figuring out why it doesn't work the way you predicted. All of that's extremely important, but it doesn't work until it works over the air, and we're really, really close to both sides, the downlink side from the satellite, the uplink side. All of that is approaching working over the air very quickly. So thank you to everybody that is working very hard on ambitious things. All right. I think that's all I know about for Opulent Voice. We do have some more additional components engineering and some board layout work to do that's coming up for us pretty quickly. So right now what we're doing is we're using pre-existing SDR platforms like Pluto SDR, LibreSDR, if you're familiar with the HackRF or all of these different things. That's what we're using mainly in the lab, along with development boards from Xilinx and Analog Devices. So in the lab, we have like the ZC706, ZCU 102. Aaron has the same sort of stuff in his lab. And then on top of that are the cards, the radio chip cards from Analog Devices. We generally use at this point, like the 9000 series from Analog Devices. So 9009 and the 9002. And that's what's actually connected to those boards. So we call those kind of the big boards. And that's what we have available for people that would like to do open source work for digital radio. So it varies all the way from like the RTL SDR all the way up to the ZCU 102, which is an ultra scale Xilinx device. So that's kind of where we're at in terms of the span of what we tackle. Okay, so off to a completely different subject. This is a project that we have. We support AMSAT, which stands for Amateur Satellite. These are organizations, usually national organizations in the Amateur Satellite Service. So non-commercial Amateur Satellite Service. And AMSAT UK, United Kingdom, we're helping with something called the Mode Dynamic Transponder. And this is going to go on to their next satellite launch, which is slated for later this year. It's called the FunCube Plus. If you're familiar with amateur satellite at all, then you probably know about AMSAT UK's FunCube and the FunCube dongle, which is essentially like an RTL SDR for space. And this is a wildly successful project in amateur satellite, and it has helped tons of people enjoy the amateur satellite bands and to become educated about amateur radio in general, and to go on to do this either as a career or as a vocation or lifelong hobby. This next launch is the first one after a long time, and AMSAT UK is working very, very hard to make it possible. The Mode Dynamic Transponder is an FPGA-based project. And what it does is it is focused on sort of weak signal work to sort of dig out 70 centimeter, or we're talking about 430 megahertz band. What's going on the Earth, to look down on the Earth in the amateur satellite band and kind of bring out these weak signals. And that's the kind of the vision and the goal for this particular payload on this really neat satellite. And so what we've done is helped out to kind of like flesh out the technical, and all as an open source project. So the way that we kind of approached this was as a successive interference cancellation sort of thing. So we're looking at 30 kilohertz of bandwidth in the 70 centimeter amateur band. And what we're doing is we're saying, okay, look at this 30 kilohertz, and we're going to start picking off the signals. So successive interference cancellation, just like you would have in like 5G, cellular. And then you take the strongest signal out, process it. Was it an amateur signal? Okay, go ahead, send it off to the general purpose processor, go to the next one. And you do this successive sort of interference, even though these are real signals, but we're, interference cancellation. And then we're going to do that as long as we have time before we have to take the next snapshot of the entire 30 kilohertz. So the status as of right now, we approach this as a polyphase sort of thing. So there's 4 channels that split up the 30 kilohertz. All of that work is in VHDL. It's targeted for the ICE40 FPGA because that has a very low power consumption and can go into space. usually, as you've probably heard, most of our work is on like Zinc and Xilinx chips, but they consume too much power for a LEO spacecraft. This is a 2U CubeSat, so it's about yay big, and 2 watts, to 1 or 2 watts, not really can't be supported, but under half a watt, like the ICE 40 plus a STM, that works. So the ICE 40 chip is what we targeted. We're at 87% usage on the ICE 40 with a polyphase channelizer, which is essentially a spectrum analyzer. So when you think of a polyphase or multi-rate channelizer, there's 4 channels. They slightly overlap to give a smooth top to the response. All of this work is at Open Research Institute's GitHub under the Mode Dynamic Transponder repository. So it's all there. The VHDL passed all the test benches. We're waiting for an ICE 40 board to actually essentially put it on the air. But the simulation looked good. The synthesis all passed. The utilization looks good. Now we turn our attention to the other side, the general purpose processor. So this is matched up with an STM, a fairly beefy STM. And we wrote drivers for that, and it's working and passed essentially a stress test where, the driver sits there and reports all the channels that it gets, no memory leaks, no weird behavior. And so now we come to the point of the project where what do we do with the signals we've identified? Do we do machine learning or AIML? Do we do some sort of autonomous receiver? And so that's the point of the project where we are. So if you're interested in this sort of thing, like signal identification on a very frugal platform, so, an ICE 40 and an STM in space with half a watt, is what we're talking about, then please get in touch. So we would love to get a review of the work that we've done, and to really support this really remarkable and amazing organization, AMSAT UK, with a long history of providing powerful educational opportunities and projects in space. So help us make this work. The launch is later this year, so we are talking about a pretty a stressful schedule. It's got to get done, and where we're short, we're not short on like the theory, the DSP, or writing the VHDL, or even really writing the STM code. We do need reviews and somebody to come in and look at it and say, yeah, okay, good, and here you go. I can carry you through to the last bit. It's always appreciated. Where we're really short is board layout. We did lose the person that was going to go ahead and lay out the 1U cards that go into the essentially the back plane. That's where we're probably weakest. We don't really have very many people that can do the actual board layout for space. So if that's something that you've always wanted to do, or either you want to learn and you want to pitch in, or how to do this, or somebody that does know how to do this, that may be the long pole that prevents this good work from actually getting into space. Okay, so I'm going to pause for anybody else that has any corrections, additions, or updates for the MDT SIC project with the AMSAT UK. Okay, and if you want to get in touch with me directly, I'm Michelle Thompson, W5NYV. For ORI, I'm the current CEO, and you can reach out to me directly over either social media or at w5nyv@yahoo.com, and just we'll get to work on this and make it happen.
Yeah, very good evening, Michelle. This is David from AMSAT UK in London.
Oh, hi, David. Oh my gosh, I did not see you there. So please go ahead. You have the floor. Please correct me for anything I got wrong.
No, fine. Thank you very much. Been very interesting listening into the discussions this evening. A couple of points. Firstly, the launch of FunCube Plus will not be until next year. So we're looking for, we've got a bit of extra time there from what you were saying earlier. Hopefully by autumn this year, we can have the Mode Dynamic Transponder running on something like a set of dev boards, or anything that we can put together in the lab and just check it's functional. And then we've got some time into the early part of 2027 to actually get it onto a board, and then integrated into the satellite. Locally, we're using KiCad or KiCad, depending on where you come from, for PCB layout. It's a very intuitive piece of software. It's a free download. And certainly there don't seem to be any limitations that would stop us putting FPGA or processors on board those. We've used the STM32L4 that I think you mentioned in an email to me earlier in another part of the project. So we know that one performs very well and is low power comparatively. It's just a question of does it have enough processing power for this particular application? But thank you very much for advertising. I hope we get some takers to assist with the project.
If it is delayed, then yeah, we can definitely have the dev boards that we have coming in, that we already have on hand and that are coming in soon. That's going to be very quickly demonstrated, and then that gives us time to actually lay something out that's intelligent and solid and good and reviewed, because we really like design reviews here. So thank you so much, David. I really appreciate all of this, and the information's good. It's good news. And we'll just keep we'll keep working as if it was in October of 2026 and not sometime in 2027, and then will give us plenty of margin. So thank you so much. This is a really neat project. So if you're interested in learning about FPGAs, you like open source designs, you like amateur radio, you want to support amateur radio satellite, if you are in the UK, please check out amsatuk.org, and or it might be a dash in there, but you'll find it, you'll see it. And if you're not familiar with the original FunCube, that is a really awesome satellite. So a landmark effort. So please check it out. And if you get in touch either with David Bowman directly, the AMSAT UK folks directly, to help out on this project, or me, and we'll get you started and supported. Okay, so the next item that I have to bring to everybody is just an update on our demonstrations. I said we're demonstration forward. We do have demonstrations coming up at several events, and we have kit sales from things that we've done, like the RF Bitbanger. We have a capture the flag or a competition, and this is or CTF coming up, and also some giveaways at B-Sides San Diego on the 4th of April on 2026. So if you're in Southern California, anywhere near San Diego, we'll be there doing things and demonstrating our work and providing an educational capture the flag. It's based on a lunar lander from India. So the Chandra lunar lander from 2023. What we do is we took the paper from IEEE and we re-implemented their design as specified in the paper. This was really super fun. They did this in VHDL for the actual lander, but they don't publish their VHDL. What they did is in the paper described very, very clearly the altimeter, the radar altimeter approach that they used. So we re-implemented it in Python and found there's some cool things that happen that go. I'm not going to give away too much, but if you know FFTs and you understand what's going on with radar altimeters, you can easily see where you need to head off a big bug. And so we turn this around and present it to the community and to students, because this will be at SDSU, as a challenge. Like, can you solve the problem for the lander? Can you make sure that it lands without crashing? So that's the idea of the CTF, which is also in our repository. So there's all of that's open source and can currently be found. Then we will be going to Friedrichshafen. This is in Germany in June 2026. It's called Ham Radio. It's a huge amateur radio Hamfest convention event, and we'll be presenting to the European Space Agency all of our work that we have done so far to try to represent the digital, regenerative multiplexing, sort of every FPGA heavy digital designs in order for the next geosynchronous amateur satellite program. So the ESA, European Space Agency, very interested in making this happen. The current QO100 payload from AMSAT DL, from the German AMSAT organization, is a little more than halfway through its lifespan. This has been a wildly successful amateur payload. and the ESA is interested in a follow-on. And so they have put out to the amateur and experimental and academic community a call for designs. And we've responded with ours. In our view, so a little editorialism here, in our view, there's really only two ways to approach this when you have a communications payload. You can either do a bent pipe, a transponder, linear transponder, that just whatever goes up is sent back down. It's a mirror. You just reflect it back down. Or you receive the signals, usually like some sort of digital signal with FEC, with all sorts of, digital modulation and encoding. And then you reconstitute everything in the payload and then you retransmit it back down. So when we say it's a retransmitting transponder, that's what we're talking about. And this allows you to use all of these amazing DSP things that we know about, forward error correction, and all the protocols like DVB-S2 or, Opulent Voice. So that's what we're going to demonstrate, is to show that the community really is ready and capable of producing, the open source community is capable of producing these sorts of designs, and they should be in space. And with the ESA, it's a funded opportunity for development and to show the prototypes. And so in June, that's what we'll be presenting in Friedrichshafen. So if you are in Europe and unfamiliar with Friedrichshafen, it'll be in June. Check it out. It's a really interesting thing. And it's also co-located with a major astronomy show as well. So then after that, our next major demonstration will be at DEF CON in Las Vegas, Nevada in August. And it's a cybersecurity or hacker convention. We'll be at RF Village, and we'll be showing everything that we have working in August of 2026. Beyond that, unsure, but we do prioritize demonstrations and showing the work and publishing everything on our GitHub. So if you go to GitHub and go to Open Research Institute, you can find all of this work in all of its various stages. And if you see anything you're interested in, or if you see, or if you know of a project that you think we might like, let us know. We're here to help projects thrive, and we're here to help individuals find their future through open source digital radio work. It can help you personally, educationally, and professionally, and that's what we're about. Okay, and that concludes all that I have on my list. So I'm going to open it up. If Oscar or Paul or Rick have anything, or Aaron has anything additional. Oh, and I see Evariste. Evariste, if you have anything to bring, then you have the floor.
Thank you. You are doing a wonderful job, and it's very cool for all the demonstration and the next show. I'm working right now on fast sweep for the AD9361, and so the Pluto clone. And I can maybe share you my screen, which is
yes,
one.
You should be able to.
Okay, so the idea here is to get a spectrum from a Python script, which means that here I get 4 gigahertz of spectrum here. So from nearly 80 megahertz to 3.9 gigahertz, right? So it uses the FFT done by Maya SDR and a mode which is fast lock, which normally allows to sweep between 8 profile. So we have 8 profile of 60 megahertz band. So normally it's limited to 480 megahertz. And then here on the Python script, at each time there is a loop, I change to another profile. And so we can have a lot of profile like that and extend the sweep. So here, if we can see what this is the Maya spectrum, and you see that well, it roll along all the profile, and the Python script know that you switch from one spectrum to another, and then you can have this kind of spectrum. The idea is here to display it, but we can also use some part of the bin of the spectrum to analyze some particular event, but we have a wide spectrum here. That's what I'm working on. And just for curiosity, I do something with Claude AI here, and as Amaranth, which is the base of Maya SDR, is Python-to-VHDL transcriber. And as soon as the LLM know well the Python, it's easier for LLM to write code in Python and then use Amaranth to transcribe to VHDL. So just by curiosity, I try to write DVB-S2 RX in FPGA with this method, and for the reference, I tell it that, well, for example, SatNox have a DVB-S2 receiver, and so it's easier to tell him all the steps. And it's really curious to know if it could work. And so you have here all the steps done by FPGA, but the LDPC will be done in ARM, because LDPC is well, we need a lot of LUT to do that. So we try to get it on the ARM. That's just a little work I did this afternoon, just by curiosity, to see if we can have a proof of concept of this kind of thing. That's it for me.
Wow, that's a lot. And it's no, it's right in the a lot of us are grappling with and working with and either getting a lot of progress with large language models like Claude,
yeah,
and AI and ML. Well, we actually have an article coming out in just a month or two where we used machine learning. So we just made a straightforward machine learning model to decode RTTY, or radio teletype, which is a pretty interesting protocol. So that's going to come out in QAX magazine in a couple of months. But that's a straightforward machine learning model. What you're talking about is using large language model to grapple with Amaranth, which is the Python-to-VHDL layer, a sort of a language adaptive layer to produce something that works in VHDL. So thank you. This is really very interesting work. So Evariste, if people want to find out more about Maya SDR, where do they go? What's the best place to go for Maya?
Well, the original Maya SDR is on the GitHub from Daniel Esteves, and I have a fork. So on my GitHub also, so all is open source, and you can reach all that. Daniel has made some explanation about how he did the project, but that there is some missing documentation about how to add another component with Amaranth, for example. and more and more I can I succeed in having adding component with Amaranth. So I try to suggest him or make a pull request to his documentation in order to people to coming to Amaranth.
Okay. Yeah, I put in the chat, I put maya-sdr.org.
Yeah.
That's what I have as the place for
Yeah,
finding
yeah, yeah.
more about it. So when so Evariste is showing you the use of Maya SDR. So please check this out if you are interested in software-defined radio. We use Maya SDR in the lab. Essentially as a different type of spectrum analyzer. So we have Paul, correct me if I'm wrong. We have a Pluto SDR that's set up to run Maya SDR, and we use this as an instrument because it is faster than our very expensive spectrum analyzer and shows you different aspects of the signal. So we find it extremely useful, and not just as a tool. The actual artifact, the code is useful, but the way that it was made. When we talk about Amaranth, this is Maya was produced using Amaranth, which takes Python and turns it into VHDL. Let me get the best link for that.
I can find where I can stop my sharing screen.
Yeah, I have the GitHub. I have the GitHub for Amaranth. So, I mean, if you're interested in like leveraging Python to make VHDL, then it's worth a look. So like that's the GitHub for Amaranth, but that's maybe not the most friendly way to find out about it. It's let's see, there is okay, so there's an amaranthlang.org. So this might okay, there we go. Okay, so if you would like to not just look at source code, then it might be the best way to do it. Okay, so that's Amaranth. So we're very interested in these sorts of projects because as an open source digital radio organization, and we do technical work and we also do regulatory work. So we're interested in all the aspects of moving things forward. Amaranth is a big part of that. We really would like to see this successful. So it's something that folks should know about. All right, Evariste, anything else? Anything we missed?
No. Okay.
Yeah, very good. Yeah, thank you for all the hard work and amazing stuff. So if you're not familiar with Evariste, his amateur radio call sign is F5OEO, and he is a class act. You check out his all of his repos on GitHub because he is a proponent of some really good SDR work. Okay, that's all I've got. Anybody else have anything for the roundtable? Okay, Oscar, anything that you want to bring up or bring to the table or tell us about?
No, I've been listening and learning a lot as well. So at the moment, I will keep quiet. Thank you.
Okay. Yeah, thank you. Oscar teaches at the University of Puerto Rico, which is a university very involved in rocket launches, sounding rocket launches that teach students very directly with deadlines and actual launches, like how things work for engineering and aerospace and science. So their science payloads are fantastic, and we support the University of Puerto Rico. And if you are interested at all in getting involved, then this is all through NASA Wallop's RockSatX program. So check out the RockSatX program and see if it might fit your academic program, because it's really good stuff. The students learn a tremendous amount.
I have to say something. This year, we are introducing as you are doing as well, the machine learning with all the algorithm for real-time data analysis during flight. So it's not centralized. It's done by several 4-core ARM computer and a Halo 8 to do the artificial intelligence, to do the analysis during flight as real data. So we're struggling. We have it running. We have it set up. I can send you our today NASA presentation of the advances that we have done in the last 3 months. And definitely this come to stay. So instead of getting the data and analyze it afterwards, we're teaching the models to do the analysis during flight in real time. So we are using like a neural processing unit with typically about 26 thread operation per second, and it's doing a standalone inside the payload with the computer of the payload. So this is also introducing these factors, and it is quite interesting. So what I'm going to do, I will send you our presentation with our software, including a structure how to teach other people about this AI story. So let me send you this email that I have been working this morning. And it's because it just work. And we are not going to be everywhere at the same time. So this learning procedure of machine learning and artificial intelligence that we need to teach it when we are not available, and actually our thinking can fit into a computer and do the analysis. So then it's working. So let me send you this thing, and we will chat later on. And what you're doing is on the right track, and you're ahead of competitive around the world, because everybody is developing these skill sets, and we have to take advantage of our technology. So thank you, Michelle. I'm really happy to be here and learning a lot. Thank you.
Oh, thank you. All right. So, Rick, you want to give us a update on any of your efforts to track to get? Let me go ahead and introduce you. So Rick is on the board of directors of the Deep Space Exploration Society, and what they do is amateur astronomy and amateur radio and amateur radio satellite as well. So this is a really neat site in Colorado. They took an old radar dish, a big 18-meter radar dish, and rehabilitated it and got it working for academia, for education, and for non-commercial amateur use. So amateur astronomy is a big deal, and so is amateur radio. So Rick is a very important person at DSES, and one of the projects that they're doing, and they're enrolled or accepted into the Artemis II effort to do the Doppler tracking of Artemis II mission to the moon. So this mission has been, the launch has been delayed a couple of times, which, like I said, is a mixed blessing. But as one of the 34 stations around the world that are kind of official reporters back to NASA for the mission, Rick has helped organize all of the, all the effort to set it up for Doppler tracking and to get things working. And this has been like a three-pronged deal with timing base, and also the radio part, and also organizing the volunteers to staff it, because it's not just a 4-hour window that we're talking about. This is many days. So I'm going to turn it over to you. You can close us out for the meetup. So tell us how it's going, Rick, and if any interesting things that have happened over the past week.
Yes, I see you have quite a lot of people logged in today. So that's interesting. I just sent out the link to the website for the DSES Deep Space Exploration Society website, in case anyone's curious about that dish and what we do with it. Our immediate goal is the tracking of the manned space mission to and hopefully back from the moon. It appears very likely that the launch will occur on April 1st. Maybe. That's a very definite maybe. They're rolling the rocket back out to the pad. It's my understanding they're not going to do another wet test. They haven't done well with those. So anyway, we'll be ready. We are still trying to improve the performance of our system in advance of the tracking, and we've only got 2 weeks left. So some of the guys are coming over here today to complete an analysis of the feed for the dish. The feed was removed last weekend and brought to Colorado Springs for analysis. And half of that was done at Ray's house, and the rest will be done at 1 o'clock Mountain Time here. And we'll try to get it back up, mounted in the dish and tested with our beacon, perhaps this coming weekend. We're cutting it close, but every week we try to improve the performance of the system we have. So we'll see how that goes. Anyway, once we're done with Artemis, we go back for a while to radio astronomy. And while we set up another advanced system for the October Earth, Venus, Earth phase 2 experiment, we're trying to bounce a signal off Venus, which is not easy to do, and if possible, actually incorporate some information in that signal. So we're in the process of putting together a 1.5 to 2 kilowatt transmitter for 2.4 gigahertz ham band to use in that experiment. And then whether we succeed or not, we'll give it a try over a 10-day period in October. And then we go back to radio astronomy again. And we're also looking to try to finalize the plan to put up a second dish, the 30-foot dish that we recovered a year or year and a half ago. And we're ready to put that back together again once some concrete can be poured. And that way we can have EME and terrestrial communication with the 30-foot dish while leaving the 60-foot dish as much as possible in the radio astronomy mode. So, and if you look at the website, what I just said is about 4 things out of a dozen that we're doing. Just check the project list and the science list, and you'll see that we're doing quite a few things. Fortunately, our membership is growing and we have many dedicated people. We even had a high school group at the site learning about science from the underserved communities in eastern Colorado. And we're very pleased with being able to bring those students in and show them what we're doing and try to encourage them to pursue science as a career. Anyhow, there's lots going on, and hopefully I'll find some time to contribute to Michelle's projects soon in my spare time.
Yeah, look forward to that. So what we have done for the Earth Venus Earth effort, and this is the effort that has some history to it. So dating all the way back to 2008 was the first time that the amateur community was able to do a Earth Venus Earth bounce signal. So if you're not familiar with this type of effort, Earth Moon Earth, or EME, is actually a very active mode that's been done for decades now. And what amateurs do is that they use the moon as sort of a natural reflector and bounce signals off the moon. And so EME folks then point their antenna at the moon and bounce the signal off the moon at all sorts of different frequencies, all the way up to microwave, and then look for responses from Earth stations. So a relatively small community, especially when you compare it to like CW contesting or SSB contesting or any of the other HF shortwave listener communities. But it's been going on for a long time, and it takes a lot of skill and a high performance station, because when you talk about the moon versus a terrestrial station, you're talking about a lot of path loss. And interesting things happen to your signal when you go through the atmosphere out to the moon and back. Okay, well, that wasn't hard enough, obviously. So we need to tackle the next planet. So that would be, or the next planetesimal, the next moon, the next is a spherical object, and that would be Venus. So in 2008, AMSAT DL fired up a station and aimed essentially a carrier wave, a carrier signal at Venus, and received it. So big deal. That, you know, that's like the hello world of radio. So what we're trying to do here is to step up from just a carrier signal, just a continuous wave, and actually put information out there to get information back, a message. And this is a step forward, because in order to put information on the signal instead of just a carrier wave, that means that the signal to noise ratio has to be improved, that your link budget has to be improved. It's harder to get information through a channel than it is just a carrier wave. Last time around, about every 18 months, Venus and Earth line up at the closest. And that's where you should try this. Because again, the path loss for Earth to Venus is enormous, way more than the moon. And you want to try this when Earth and Venus are at the inferior conjunction or the closest together. That's going to happen next in October of 2026. 18 months ago or so, we tried this, and we tried to put like Zadov-Chu transmissions from a number of different stations around the world. But all we really got through again in that attempt was a carrier wave, because as we found out, firing up a transmitter at these power levels without a lot of advanced preparation and like, sort of like, essentially, if you've ever done theater or if you've ever done a performance of any type, you need to have rehearsals, many practices, a dress rehearsal. You can't just change your equipment out and pray. Sometimes it works, but this time for most people it didn't. So this time around, things are being done further in advance. And what we're going to try to do for the first time is to bounce a signal off of Venus that has information in it. So that's what Rick is talking about when he talks about EVE or EVE, the EVE project. So if you're interested in this sort of thing, check out EME. There's a really good article on Wikipedia about it. And EVE, Open Research Institute did a link analysis in Python. So this notebook is in our repository and has been in our newsletter. That's our service to organizations like DSES. And it shows pretty clearly that there isn't really any amateur mode that can do this, that you have to construct one specifically for this channel. So you have to look at the channel. You have to look very carefully at your equipment. These are big dishes that can do this. We're talking 18 meters, 20 meters, 25 meters, that sort of, you know, dish diameter. Or if you have the equivalent in a distributed receiver transmitter sort of situation, if you have, you know, an array. So like if you think about the very large array, the VLL array. So if you have a lot of smaller antennas and they all are pretty high performance and you've got them all in an array, you can close this link. The path loss is huge, but what you really have to worry about is things like Doppler. So there are several different types of Doppler with this particular situation, and there's an interesting twist. So there's a plot twist with Venus. The Venus rotates in the opposite direction that the Earth does, and what this does is this actually kind of helps us. So when you look at the rotations of, you know, it rotates about its axis, they're rotating opposite each other. And so that actually is reflected in our link analysis and described and discussed. The best frequency for getting the most kind of like radar return off of Venus is around about 2.3, 2.4 gigahertz, and both DSES and all the other large stations out there are going to move to that. The previous attempt was at a lower frequency. So if you're interested in this, the EVE project is ongoing, and this is a consortium of different organizations like ORI, like us, DSES, Doingalo, StockArt, and a few others around the world that are really invested in trying to make this work. Possibly Hat Creek and others like that. So if you're interested in this, please get in touch because it's really fun. Everything is open and published, and what would be really neat is to meet up in Friedrichshafen in June in Germany at that event, or if you know of another meetup with amateur astronomy folks, then please let us know because we'd love to talk about this and to coordinate. All right, we're just slightly over time. I apologize for that. For me, it's 7 past the hour, and what we'll do is we'll close out the roundtable discussion for today, and then we go into open office hours, and we're here to answer questions and to just basically ask us anything or bring up a project that you think would be of interest to the open source digital radio community. Or share what you're dealing with. So everyone's welcome to stay and to talk until anybody else until everybody's gotten a chance to share and to ask about things and to share things that they care about. And then Soham says hello. Hello, Soham. Very good to see you. Very good to see everybody. So yeah, anybody has a question or comment or anything that they want to bring up about either amateur radio or open source FPGA design or workforce development about FPGA work. There's not a whole lot of open source work in FPGA design, but what we've tried to do is make this accessible to where folks can learn and get enough leverage to where for their either personal development, their educational development, or their work, professional development, that they can get some traction here. So yeah, any question, happy to talk to anybody about anything. John says might be able to lend a hand with circuit board layout. Thank you very much. Oh, good. A few boards in KiCad, you're ahead of me. Board layout, not a strength for me. We have a few folks at ORI that have done the boards, but please, John, you're extremely welcome. If you're not already on the like our email list or on our Slack, then you can go to it's openresearch.institute getting started, and I'll put it into the chat. Okay, so that should work. That's the place to go in order to sign up for email list or the or Slack. That's where kind of the daily engineering happens. The email list is low traffic, not high traffic list, mainly for announcements to let people know about meetings and big events and our newsletter. We have a newsletter, so if you just want to keep up with the newsletter, that's on our website, openresearch.institute. There's about us, there's a newsletter. So thank you, John. And yeah, sorry if I didn't catch you, Aaron, see you next week. And then Soham says, I'm a student, 4th semester. So I think second year, end of second year in Triple E. And since last semester, due to project submissions, I came to know about ham radio, SDR, and FPGA. I'm really interested in starting with them. Well, welcome. It's a messy, kind of difficult, awesome, cool hobby. It's sort of like messing around with hot rods and cars, so like making a car go fast. Yeah, just welcome. It's really, really neat. And the best way to learn is to just dive in, pick something, start messing around with it, and ask questions. This is who should I contact for FPGA and SDR related development and where? Okay, so again, kind of a messy thing. There's a lot of different places to start. You can get some good traction. Well, I mean, with us, we could probably help you get started. Since we're kind of focused on practical implementations and the engineering side rather than, I mean, we are conversant and with it on the theory side. I mean, you can sit with the textbook and learn about all the FPGA, DSP stuff, but the best thing, in our opinion, is that you pick something that you want to do. Like you want to, your radio, you want to see your radio do something you're interested in, and then you make that happen with whatever you can afford. And once you kind of get your claws into it, you know, and you're like, you get some traction, then the world starts opening up. So pick something that you want to accomplish and then go do it. And this is kind of messy work. A lot of times people will recommend you to go like get GNU radio and start playing around with that. I'm not sure that is the best entry point. So I'm going to put it back to you. Like, what do you want to actually like do? The hello world of DSP FPGA is usually like getting your local radio stations, like either FM or AM broadcast stations, coming through on something you designed. That may be a good starting point. Or there may be something on VHF or UHF that you're interested in. Like for instance, there's a whole lot of IoT or telemetry reporting, tire pressure management systems, you know, on 433 megahertz, that sort of thing. So it just kind of depends. There's a lot in amateur radio. So if you're already familiar with ham radio, you've got a really good entry point, and you should have a lot of people that are near you that can give you really good advice. And if not, just go to our getting started and get on our Slack, and then we can talk more there about getting you started. If you don't already have an RTL SDR, that's a really good place to start, because then there's like dozens of different designs on GitHub that can turn your RTL SDR into a receiver of dozens of different types of receivers. SatNogs is another really good project. So SatNogs is with some effort on your part, you can develop a station that then can watch the sky and receive dozens, if not hundreds, of satellites that are, then you would track them with your station. So you're going to track them. Your station's going to automatically know when they're coming over, track them, and then you contribute that reception to a centralized database. So SatNogs from Lunar Space Foundation is a tremendously successful open source. It's one of the largest distributed receiver systems in the world, and they're very amateur radio friendly. So those are the things that I would point you at. But you know, and I know you're a student, so you're already really busy. So I know I've piled on a lot of stuff to recommendations. But yeah, please sign up and reach out on Slack, and we can help you and support you. This is a wonderful world. There's never been a better time for this sort of radio. So the combination of like FPGAs, software-defined radio, super powerful, you know, small, amazing general purpose processors, and even graphical processing units, GPUs. We've never had more powerful radios, and you know, software has never been better, really. So it's a golden age for radio, and also for amateur radio. It allows you to transmit. The big value for being a ham or an amateur radio operator is that there is no other way to build a transmitter. If you want to transmit over the air, you usually have to have a very expensive or restricted broadcast license. But as an amateur radio operator, you can build a transmitter, and you can transmit on bands from very low frequency all the way up to microwave. So there's lots of allocated bands just for you to be able to try out your ideas. And it's essentially free or very low cost to get this license. Let's see. Any other questions? All right. Any other questions or comments? You can either put them in the chat or say them out loud. Any comments or any questions or any ideas or anything anybody wants to share, you're welcome. Okay. Well, I think we'll close it down. for the week. We do this every week, and we try to include the community and talk about all the different project progress that we have and all the different organizations that we help support with technical work. Oh, thank you. Thank you for the compliment. Now, we also do regulatory work as well. I don't have any recent regulatory efforts or updates to share with you, except for IEEE. We're involved, we're a member of the, that's called the P1954 standards group. And this is looking at standardizing drone physical layer. So for drones, for in formations, drones are big, as you know. And so our kind of effort there is to make sure that open solutions, open source solutions for drone physical layer and also for the command channel are all represented. And at the last meeting, the standards group accepted our kind of bid for providing an implementation or a reference design in open source. So this would be an OFDM physical layer, probably using our Neptune project, which is a drone physical layer OFDM work, and then possibly using Opulent Voice for a resilient, command channel, because Opulent Voice has a lot of soft decision forward error correction and is pretty resilient, and also resilient and to Doppler as well, which with drones, that's a very challenging thing, but lots of Doppler with drones. So from the regulatory or standards side, that's a little bit of progress that I have to share. So if anybody else out there from IEEE is involved in standards group, please check out 1954 to see some of the work that we're involved in. And if you know of another IEEE standards group that might benefit from a little more, a little bit of a voice from open source work, then please let us know. Let's see. Rick, I think I heard you. Did you speak up?
Hello.
Oh, go ahead.
I have one thing, but I want to talk with you and maybe Paul alone.
Oh, okay. Yeah, when we close down, we'll talk more. I'd like to thank everybody so much for coming. We know that time, once you spend it, is gone. So spending an hour or so with us is deeply appreciated. And if you'd like to know more about Open Research Institute, then it's Open Research Institute, openresearch.institute on the web. And we are very thankful to the San Diego section of IEEE for the support. We interact and support the work from the San Diego section as much as we possibly can. And our next event in IEEE San Diego section will be at the Del Mar Electronics and Manufacturing Show. This is in late April. So if you were there, and drop by and see us at the booth. And if you have an IEEE event that you would like us to talk to you about, then please write me, let us know, and we will help share it through San Diego section of IEEE. Okay, everybody, I'm going to leave it open for any last questions or comments, and then we'll close the meeting for the week, and we hope to see you again next week.